Hi, my name is Sebastián Pozo. I like to develop software that improve the process of structural data. I want to study abroad in the area of seismic structural design, and my aim is to achieve a scholarship in order to study a master and a PhD.
Hi, my name is Caterina Nieto. When I finish my undergraduate studies, I want to get a master focused on soil mechanics. I want to study abroad so I can learn new methods that helps the development of construction. Then I'll be glad to return to my country and apply this new knowledge.
Hi, my name is Sebastián Torres. As a student of civil engineering, I am interested in the design of a structure. I want to study a master relative with my interests, specifically concrete and steel design. In 1 year, I will graduate from college and I am looking for a chance to study off of my country.
Hi, my name is Juan Sebastián Zambrano. I'm interested in the use of technology like drones to develop methodologies to analyze the movement of structures over time. I want to get a scholarship to study a master program related to the spatial analysis of structures and terrains.
We are students of the last year of civil engineering. We developed an algorithm using MATLAB code that can be used to solve and calculate two-dimensional trusses.
Some of the main features of the software are use of different material properties, use of different section properties, enter data about its geometry, connectivity, and restraints with an interactive interface for the user and importing from the software's app. The user can save each job to open it later or check previous trusses from other files. The results of displacements, forces, geometry, and sections properties can be exported to an Excel file to print the data or manage it.
To run the program, it's needed to open MATLAB script and run it. In the first window, it appears the option to introduce the properties of the material that will be used for the analysis. There can be introduced unlimited materials, but the first one will be assigned for each element created.
The next step is to input the sections. In the same way, the first section will be assigned to all the elements, but it can be changed. After that, the user can proceed to draw the truss or import it from SAP.
To draw in the interface, the user first has to place the nodes of the truss. If any node is incorrect, it can be erased pressing a right click with the mouse.
The next step is to assign the node properties like its coordinates, nodal forces, restraints, and node displacements. Any change must be saved to change the properties of another node, and every saved change will appear in the plot to know that it's correctly applied.
Then the user must change the action in order to draw the elements between the nodes. The order of the nodes and the elements do not have any restrictions, but follow an order is always recommended.
Then the user has to return to the main menu and there can choose the element properties. In this section, the user can change the material and the section of any element. And also the user can input conditions about nodal force like temperature and length variation for each bar, and distribute force with the coefficients of a polynomial equation. In the same way, any change must be saved to be applied.
Finally, for the calculation, the user has two options. By the one side, it can be made a linear analysis using the forces that were input in the previous steps. The results will be presented for each node with the reaction forces and its displacement in global coordinates. For each bar, the user can view the forces and the stress applied. An additional thing is that the user can change between the forces plot and the displacement truss plot.
By the other side, the user can make a non-linear analysis of the truss, giving an increment of load in any node. The user must select a control node to determine a limit deformation when the analysis will stop. All this process can be recorded in a video at the end of the analysis. Also, the software presents a stiffness plot of the control node. All this information about geometry, restraints, and forces can be saved into a MATLAB file for future revisions.
Here you can see an example of a more complex structure in which we apply a linear analysis and a non-linear analysis.
If we choose to export the results to an Excel file, the software will ask us where we want to save it, and we will need to give it a name.
One of the features of this program is that we can import data from SAP. Here we have to export data of coordinates and restraints. Then we click the Import menu and select the file generated from SAP. As we can see, the plot structure has the same features of restraint and coordinates than the structure in SAP. This program has some strong points, however, it's just a first draft. We want to improve the input data and add more structure to be processed. A future version will include structures as beams and frames that can be calculated with a matrix analysis method.